Hello everyone and welcome back to the final episode of our series when we are building the big end-to-end Python deep learning project. In this project we are helping the local farmer with determining which of his tomatoes are healthy and which has a disease by image analysis. In the previous episodes you can find on my YouTube channel here, we discussed the purpose of this project. We set up the environment, we did some initial data pre-processing, and in the last episode we created our first neural network. In this episode you cannot miss it because we are moving to the most important part. We are gonna learn our model to make predictions and then we will test our model with some predictions. I will quickly show you how our code will look like. This was our neural network. I explained everything in the previous episodes, how does it work, what is the meaning of everything, so go watch the last episodes and then come back. This was our neural network, this was the statistics of our neural network. We will be learning 900,000 parameters of this neural network, so it will take some time, but today's episode is about compiling our model, then training our model, and then we will do some predictions, as you can see here, but I don't want to show you too much. We are ready to start. Together we can make history. Remember, you cannot code on the paper, but some people are do it, maybe on exams on universities, but I don't know why. But in our our tutorials we will open the folder where is your project stored here. You can open also this, but I will just copy the path of this, open my favorite terminal, write here cd as you already know for change directory, paste it here and write the Jupyter notebook. It will automatically open our Jupyter notebook file. Here. Okay, I will just make it full screen, open this folder also and the tomato model. We end it here with the model creation. I will run all the cells. I will go to the first cell and press Shift Enter to all cells. I'll delete this one and just wait until it run, but it will take like 1 minute. No more. Okay, you see it's already done. Not even 1 minute. You can notice there is 180,000 parameters and in the quick demo there was like 900,000. The reason is we will alter the code from the last episodes because the previous code was like the model was too complicated to train on your local PC or notebook. It will take like 1 day and we don't want that. But I will tell you what to change, so don't worry. You see, there is one paradox. You see that this model has 180,000 parameters, but our model will have 900,000 parameters. And this model with 900 parameters will be easier to learn. Why it is so? Because the number of parameters is not only one metric to measure the complexity of the neural network. In this neural network there are just less layers and less pooling layers that are squeezing the numbers of the parameters, and that means that the end, like here, the last dense layer has like 800,000 parameters, but it is easier to learn. This means that neural networks are a very complex topic. And you cannot learn this in 1 week, 1 month, or even in 1 year. So be patient. We'll move on to the code. In the code, where is it? There is the code. We created the neural network. Now we will compile our neural network. And why we even do the compilation of our neural network when it's already created? We do it because we add some important things to our neural network, as like how we will measure the accuracy of our neural network, how each step will learn if it's good or not and stuff like that. So our model is stored in the model. I will do model.compile, and here in the brackets I will define, first will be the firstly I will define the loss function. It will be from the TensorFlow keras losses that our loss function will be called sparse categorical cross entropy, and there will be one parameter. I will explain you in a few seconds. It will be false. What this mean? The loss function help us to determine like what is the difference between our predicted labels and the true labels. For this loss function we need to some optimizer which will do the changes to the weights, and the weights will change in order to make the result of the loss function lower. That means that our model will be more accurate. And with this accuracy, let me do here just comma, with this accuracy we need to measure this accuracy somehow. In our case we will measure the accuracy with the metrics, which is the simple accuracy, like how many accuracy, how many prediction will be done correctly and how many prediction will be done like in a wrong way. There are many more accuracies that are more complex, but they are better, but we don't care now about that. I will just run the code. I have some mistake here. Okay, I know where is the mistake. Maybe here, this small e. No, now it's correct. Now it's time to learn to teach our model. I will do it simply by model.fit. The fit in the machine learning and all other areas, it means like train the model. Here I need 5 parameters, but you can put like more. You can look for this model.fit TensorFlow in the Google and find all the parameters you can change, you can add, and so on. But the most important things I need to put here: the train dataset, from the data from which the model will teach itself, then the batch size, like how many images will take the model in once. I would actually change the batch size to 16. It will take longer time because it will take like smaller pieces of the dataset at once, but my PC cannot run the 32 batch size. Not possible. And the next is the validation dataset. Val dataset. Here we put another dataset and it will do the automatic validation. Next thing is the verbose. This is just parameter to describe like what will be print when we will be training the model. Like what information do we need. There are some other options, you can also Google it. And the last parameter is epochs. It will be 8. I know that I described here that somewhere I put epochs like 50, but 50 is like too much for this model. I tested it before and 50 will take also 2 days. We don't need to do 50 epochs when 8 is enough for good accuracy. And the next things, I will delete these 2 layers, these 2 pairs of layers, to make the model like better, not better, but simpler. That's what we need to make the model simpler. And because it's like too much for your computer. I'm already telling you it will take a long time. And now what we will do, one more thing here. This data preprocessing, we need this cache are helping us to load the data only once and then reuse it. But my RAM cannot load that many data at once, so I will just make the training longer, but it will work. Save this also. Okay, I'll need to like run the code again until this one. And now I will run the training process. It will take probably an hour or more. So just quick recommendation, watch the tutorial, the whole tutorial to the end, and then run your training phase. And you can predict the images by yourself after the tutorial. So continue by watching. I will explain you what we will do after this training, but now I will stop the recording, train the model and run the recording again, because I don't know if my PC is able to record the video and simultaneously train this very difficult neural network. So see you soon. Okay, welcome back. After 2 years, 2 days and 22 hours we are back and our model is ready. In the training set, that was the data set we trained the model on, but with the validation data set, the accuracy of our validation data, I think the accuracy the validation accuracy is here. This is the accuracy of our training dataset. You see it's 96-97%, that's pretty good. If it will be like 99, it can happen that the model is overfit on our training data and it take the all anomaly points everywhere and it won't work very well on the test dataset. So that's the reason we have to test it also on our test dataset. Our test dataset, you know where is it? It is there, here, somewhere. Because we split the data into 3 datasets, the training dataset, the validation dataset and test dataset. We will use this test dataset, just writing model, evaluate, parameter will be the test dataset. Run the code. It will take some time, I have a mistake. I just made a little typo. It should be like this. This will take around 3-4 minutes. So that's not that bad as 2 years for the training of the model. If you are waiting for a start of this training or testing, it will take some time and then it will take this little time to run the whole process. But before it starts, it takes another time, but don't worry about it. The accuracy on a test dataset is 97%. It's like amazing. I don't know how I did it, but it is very good. I just try to tweak the parameters a little bit there and randomly I got very good accuracy. That is like data science in a nutshell. If I write model.params, will it do something? No, it won't. Okay. The problem is, if I save this model into a variable, I could have done this to, like, if I write this model, like this model.fit, and I store it into history, I can, for example, okay, where is history? I can print the params of the history, would I add to the training, or I can print the keys, like what is the main thing in history, what else is here. Basically I can print out the important information about our training process, but I haven't done it. I don't know why. I will not run the code again. That's like, no, I'm not doing that because it will take another 2 years. Okay, so but if you wanna do it and you listen to my recommendation, there is like the my code in the GitHub. Also follow the GitHub. Here history is equal to the model fit, and then you can do like this. History is object stored somewhere in the memory, You can do the params and all other stuff, or print out the list of accuracies one by one, anything you can do. Now we will move on to the predicting. This is the last part of this video and the project itself. We will predict some images. We won't predict all 10,000 images. Now I will just visualize one or more images to show you that the prediction is actually working on that images. If you wanna alter the code, you can alter it a little bit to predict more images at once with the pictures, and it's up to you, but I will show you one picture and then you can do more to improve. Okay, for image batch, or image batch, label batch in data set, I will do it from a test dataset. From in test dataset, take one. This take one will take one batch. The batch is not two batches, one batch. The batch is 16 images, and the tag we use when we were splitting the dataset into these three datasets. Okay, take three datasets, not three datasets. Okay, we will take one batch from the test dataset. You know how the list in Python works. You write the name of the list, in this case image, like this, image batch, and you will take the first image with the index of 0, because the indexes starts from the 0. But this is not everything. If I just print it out, the first image, I will show you, it will print out. I hope it won't take another like 20 minutes again. You see that the image batch, the first image in this batch, is only a tensor. This is like number representation of a image. This tensor because this batch is in TensorFlow, and tensor is like how the objects in TensorFlow looks like, but don't worry about that. I won't run this code again in the middle of the code because like, oh my god, like it takes like 20 minutes every time. I will just try to explain it better. Okay, first image is equal to this. I don't need the number representation of this image, I need the image actually. So I will transform this tensor into NumPy arrays, and from this NumPy arrays I can transform these NumPy arrays into S type, the unsigned integer 8, and with this type I can use the function from matplotlib, the plt image show, to show the images with this input. But I will get to this later. For now I will just create the variable with the first label, and it will be the label batch and the first label. Again, here I will do some print sentences, like the first image look like this. Then I will use that function I mentioned, matplotlib.pyplot, the plt is imported above. That's the first line. Image show, like this, and then the first image, because it is already in the suitable format. Now I will print out the first images like this. Actual label will be its label, like this first label, but this label, they are just numbers. And if you go back to your code, here the class names is a attribute of the dataset, and it is like the names of the class names. Now we have number, and if you put like 0, it will print out this name, but we don't know what number is stored here. We just write class names, the variable up here, there I showed you just a few moments before, and on the place of this index. This should be working, we will see. This is the actual label, and we need to predict the label, but our model can predict only the whole batch. So I will do the batch prediction is equal to the model that predict the image batch. Yeah, exactly like this. And this batch prediction will give the percentage prediction for every of these class names. So we need to take only the highest one, with like it will have like 99% of the accuracy. So I will print the predicted label is equal to the batch prediction of the first image. I will use the numpy function argument max to take the one with the maximum value, and here it is only like the first one, second one. We need the name of that label. For that I will use the same thing as here, the class names and the list index on this position. Here the last bracket, run the code, and we will wait a few minutes, like 2 or 3, to show us the image. It's finally done. The code ran successfully, and we see that the first image is this. The first image actual label is tomato bacterial spot, and the predicted label is tomato bacterial spot. I will run this code again to show you that it will give the correct prediction with this accuracy. So it's probably give a correct prediction, and that will be like everything for this video. I will show you what everything we have done, and in this time this code will be running. Okay, it's lagging a little bit, so I will wait for the prediction. Then I will show you the whole process of this code and how you can use it in your future projects. The second prediction shows us image with the yellow leaf curl virus, and the predicted label is also the same. It took a lot of time. No, it's like took like 1 second, but the preloading took a lot of time. And you see it also predicted the correct label. Now I'm very proud of you that you finish this whole project by yourself. You can tweak the project a little bit to learn even more. Now I will show you what everything we have done. We actually learn about the libraries, about the data pre-processing, how to load the data set, what is the data set splitting, how does it work, how to create augmented data, what is the reason of a convolutional neural network, how to create it, how to compile it, how does it everything work. You learn that training of dataset takes like 2 years, and you train your first neural network for image analysis, and you practice that your neural network predicts the images correctly. I hope you enjoyed this tutorial. If you have any comments on this series, write that in the comment section. If you like this series, hit like button, smash subscribe, share with your friends, and put some love in the comment section.